Hey guys, here's the guided assignment for chapter 26. So there's three problems. They're all related to the time value of money, or at least how we evaluate investments. Anyway, so we'll just jump into it. The first one is consider the following three projects. They have an initial investment of $800,000. Determine the payback period of each project and rank the products from desirable to most desirable to least desirable, and then what other factors should we consider? So the first thing we have to do is figure out the payback. This one's pretty easy because it gives us the projects here, and it tells us how much money they pay back each year, and then it gives you an accumulated. So the payback would just be the point at which the accumulated payback equals the initial investment. So if we didn't have this accumulated, we just have to add it up, 200, 400, 600, 800. So project L will take 4 years to pay us back our $800,000 initial investment. Oops. And then project M is going to take 3 years to pay back that $800,000. And then it looks like project N will take 2 years to do that. So you're probably thinking that was too easy, but that's how it's set up. So that's just an easy problem. So we'll check our answer. It says rank them from most desirable to least desirable based on payback. And the answer is those projects that pay back faster we consider to be the most desirable. So there's that. And then it says, are there other factors that should be considered in addition to payback period? And the answer is yes. Of course, if a project was going to pay off in 2 years and then not make any more money, that wouldn't be as good as one that pays off in 3 years but keeps making money for 10 more years. So there's a lot of other things we should consider. All right, so that was pretty easy. So the second one, your grandfather would like to share some of his fortune with you. Thanks, Grandpa. He offers to give you money under one of the following scenarios. You get to choose. So you can get $7,400 a year at the end of each of the next 8 years, or you can get $48,750 now, or you can get $99,350 8 years from now. And so to set this up, we'll just say scenario 1, scenario 2, and scenario 3. So recognize that these different scenarios, they want us to calculate the present value or the net present value of this money that we're getting. So in essence, at the end of year 1, 2, 3, 4, 5, 6, 7, and 8, scenario 1 will pay us $7,400. So each year for the next 8 years. And then we can calculate the net present value. Scenario 2 is going to give us $48,750 right now. So the net present value of money right now is the value of the money because you have it in your hand right now. And then the last one is that it's going to give us $0 each year until the end of the 8th year, and then it's going to pay us $99,350. So the question is, which one of these is the best deal? So what we do is we use something called discounting to figure out the present value, or what would this money be worth in today's terms. In order to discount, you have to have a discount rate. This would be the money that you would assume you could have been earning on that money if you had it right now. Okay, so you discount it back to the present value. So in Excel, we can use a function which just equals NPV, the rate, which in this one it says is 6%. So I'm going to put 0.06, comma, and then the values. So then Excel will solve for the net present value. You can do the same thing for scenario 3, equals NPV, 0.06 for the rate, and then for the values. The idea is that even though we have a bunch of money in the future, $99,000, it may not be as good as having some money right now, okay? But in this case, we can see that the present value of getting $99,350 in the future is still way better than getting $7,400 a year or getting the $48,750 now. So the present value of $7,400 a year, it wants rounded to the nearest dollar. I'm going to do this so that I don't screw it up. 45,952. And then the present value of getting 48,750 in cash is 48,750. And then the present value of getting $99,350 8 years from now is $62,333. All right, so it appears that in this case, scenario 3 is the best option because its present value is the highest based on a 6% interest rate. Now it wants us to do the same thing, but using a 12% discount rate. So all I really have to do is come into the formula here and change this from 6% to 12%. Again, 48,750 is going to be exactly 48,750 in present dollars. And then, all right, so here we can see that by changing the discount rate to 12%, our net present value dropped significantly on the $99,000 in 8 years. Again, that's because it assumes we could be earning 8% in the meantime. And so in this one now, our present values are 36,761. 48,750. And 40,126. So with that 12% discount rate, it actually appears that in this one, scenario 2 is the better investment. Unless this is going to be difficult. There it goes. Because it gives us the highest present value. All right. So the final question is it wants us to do internal rate of return for 2 different projects. So project A is going to cost us $260,000 to start. I'm going to put negative 260,000. That's the cash outflow in the beginning. And then it's going to pay us $54,000 a year for 7 years. So I'll number this. And then project B is going to cost us $380,000 up front. So I'm going to put that in as negative $380,000. And then it's going to pay us $71,000 a year for 10 years. So then we can find our internal rate of return by using the function equals IRR and just highlight the values. We don't have to worry about the guess. We could do the same thing for project B, equals IRR, highlight the values, including the initial negative value. So we do for both of them. All right. So now it wants the IRR for each project. For project A, it is between 10 and 12%. For project B, it is between 12 and 14%. And then which is the better investment? And the answer is the one with the highest internal rate of return. So project B. And that's it. So hopefully this wasn't too hard of an assignment for you. And if you have any other questions, give me a call.